we almost would think of quantum computing like electricity or the cloud, like you're not really using electricity as like an app or anything like that, or you're not really
Yeah.
using the cloud in a very proactive way, but these are things that are enabling the rest of your life. Hey everyone, welcome back to another episode of Everyday Data, where we explore topics in data, analytics, and AI. We're your hosts, Patricia and Zac. We are MSB AI grads from NYU, as well as data and pop culture enthusiasts. And we're excited to have another chat today. Today, we're talking about quantum computing. But first, what's in the news? What's been catching your eye in the news? So, Zac, I'm excited to share the story with you because I think it's kind of cool. Um, I I was basically reading this very long interview that the CEO of Hasbro did with a journalist at The Verge, and he basically talks about how Hasbro is using AI to sort of like move quickly on things in the toy world. And so he was talking about how they're using AI to just like create pitches, like product pitches quickly, be able to pitch them to companies like Netflix. But I thought what was really interesting is they actually also trained their AI on their IP. And so they have like AI for different products. So they have like a Peppa Pig AI that helps them co-create Peppa Pig products. And they have like an Optimus Prime AI that helps co-create Optimus Prime products. And apparently the Optimus Prime AI like just kind of talks about itself very altruistically and about like the right thing to do. I just thought that was really fun. Like, what a fun way to be
Yeah,
using
it's like
AI.
giving, when AI first, AI or when large language models, we used to give personas. And yeah, I can totally see that. Yeah, you're designers, you're trying to get in character. Why not make the AI be the character you're designing? It makes perfect sense.
I think it's so interesting because could you imagine just like having a conversation with Peppa Pig about like what types of products to use to kind of promote
Yeah,
her own persona? Like,
yeah,
I just think that's so interesting.
that's awesome. Yeah, that's a perfect use of AI. Yeah, to be the persona, but with the expertise of an AI model that, yes, design products. It's amazing.
So funny. I could just imagine the Peppa Pig AI just being like so sassy because Peppa is so sassy. So I just think that that's really fun.
I love that. Yeah, that's a great story. So my story is similar because just a couple days ago, so I also have a game related story to share. And that was with Pokemon Go, a game that I love. It's celebrating its anniversary. Or Pokemon's anniversary is happening. Pokemon Go is on its 10th anniversary. So if you can believe it, 2016, here in the US, Pokemon Go to the polls. You remember our election. Um, yeah, that
Yes.
time was a special time. I remember vividly playing Pokemon Go outdoors, groups of people. But with that, as we're talking about data and AI, one of the big things, if everyone knows about Pokemon Go, is the whole point of it. What made it cool was, yes, seeing Pokemon in the real world. So, with that, yes, the company behind Pokemon Go is using all that video data you captured to make Pikachu appear in real world surroundings and parks. And they're using that to, of course, yes, train artificial intelligence and models, large language models, not large language models, but video models of to use, yes, like pizza delivery robots and learning how to navigate the real world because they have all this user data of real world locations of having Pikachu and Charizard, all your friends in the real world. Then as I was looking up this one, because this story was in the news if you follow Pokemon Go like I do. And then related, there was a China story, which is very similar, and that was about China making AI schools or robot schools for AI. And their, I guess, approach to it was, I thought, very fascinating because instead of what the West is doing with Pokemon Go by using video data to train the AI, China's approaching it from the opposite direction and building a school or like a mock factory that has certain guardrails that the AI can then learn from to train the models in a more structured way and then can be extrapolated to the chaotic environment of a real factory floor. So it's this kind of similar approach of putting real world or putting AI into the real world, and which is kind of the next step of AI, right?
Well, it just feels like it's always going to be a race against this country doing this and X
Yeah.
country doing that. So I think it's going to be really interesting to see what happens with China, but also on the Pokemon Go piece too. Uh, right now, the internet is obsessed with 2016. So I think it's so great that this is making a comeback because 2016 is everywhere. Like everyone's calling 2026 the new 2016. So it's no better time than time
Yeah.
for Pokemon to come back.
Yeah. 10-year anniversary. Yeah. Drag it, pull out your old phone, get on the Pokemon Go. It's still fun. I enjoy it. My son and I play it. It's fun.
I haven't thought of that game in so long.
But on that note, so what are we actually talking about this week? So I'll quickly set up. So we're, as Patricia mentioned early on, we're talking about quantum computing, and it sort of plays into this idea that we briefly mentioned about countries trying to outpace each other, and quantum computing being the next frontier of not just AI, but computing in general. So our sub kind of title for this podcast is why you and your mom should care about quantum computing. So we're going to try and break this down, which is a very complex topic. So we're going to break it down to the everyday. So I'll start off with my absolute basic understanding of quantum computing, and then I'll kick it over to you, Patricia, to share what we've been researching ourselves and just reading up on over the past year or so, where quantum computing has come into the forefront as kind of the next frontier. So, in a quick, super easy nutshell, what is quantum computing? Quantum computing is that next step where, at its basic level, like what I learned in computer programming, computers are composed of bits where you have an on or off switch. And that is, if you ever looked into how a computer works, that is how it works at this atomic level. That is a flow of electricity turning a literal physical switch, but now it's sort of abstracted to be on or off. And you can abstract on that layer of on off to do math. And it's very crazy to learn about just on off. But what quantum computing is, it's in the popular culture, it is sort of like multiverse because it is with this thing they call superpositioning, popularized in things like Dark Matter, the book and Apple TV series, where instead of being in that on or off, just single two states, these particles, these qubits, which I'll have you explain in a little bit, Patricia, can take on any state. So they can be in any position, not just on off. They can be that spectrum, sort of an analog as opposed to digital, where digital is just on or off. Quantum makes it analog. It can be the range, an infinite range between on and off. So that was my super basic. If my mom had to know just one thing, maybe it's that, but maybe you can expand on that, Patricia.
Honestly, I think you did a really great job of it. Like,
Yeah.
I don't know what else I would say because you basically got it, right? Like, I think the biggest difference is that we have bits, which are either 0 or 1, and then we have qubits where you could be 0 or 1 at any given state, and that ability to be either or at any given point or at all times actually is basically called superpositioning. And so your compute power is just grows so much because of that. I mean, quantum computing gets a lot more complicated than that. I would say this is probably like a good place to kind of leave it in terms of this is the basic of what quantum computing is. It's really just like taking that compute power and really improving it and providing opportunity to make more complex calculations. And I mean, there's lots of other components to this. There's like the concept of entanglement, which is basically when you're connecting your qubits. So the information is all connected. There's the concept of interference, which you can look up, which is basically like how your computations are coming up with like the most probable correct answer. And then there's a concept called decoherence, which is like if there's like a little something wrong with the surroundings of the qubits, like if the temperature is a little off or if there's like a little vibration, basically the qubits all lose their superposition and it takes everything and kind of blows it up, which is why quantum computing is still so fragile, is because they haven't really been able to 100% solve decoherence, although apparently Google did just in the fall. create a chip that was able to solve this. So I think that things are about to start moving very rapidly in the quantum computing space. I think up until now, it has been considered just like very fragile, hasn't really had a lot of real world applications. But with some of the new, I guess, like movement in this space, I think, especially with Google's new chip that has kind of stabilized the qubits, I think that things are about to change very rapidly.
So this is a real technology, right? Just to kind of set this, it's not like a cold fusion where it's a theoretical thing, right? There's actually quantum computers, right?
Yeah, they look like chandeliers.
Okay.
And it's really interesting because, like, you see these, like, big structures, and you think the entire thing is the quantum computer, but it's, like, a small chip at, like, the bottom. The rest of it is just cooling systems because it needs to be at such a low temperature. But, yeah, there are quantum computers that are out there right now.
So we talked about, yeah. So this is a real thing, and I guess for the lay person that hears all these terms about AI, we know about GPUs. So GPUs are what it was a breakthrough that allowed the operations that power AI to
Yeah.
work in parallel and perform better. So how does quantum computing, like, I guess, impact us? Why is it the next frontier?
Yeah, so I think what I would say is it's really compute power for quantum computing. Like I don't know that it's not really going to make AI any better, right?
Mm,
Because AI is just kind of predicting patterns, whereas with quantum computing, it's really just like the complexity of problems. So it's what it's going to do is enable more complex problems. So I think where we'll see it come to life is in, those like optimization problems. You have like a million flights
yeah.
and flight routes, and you need to figure out what the best route is. Right now, AI does do that work, but it's a little bit more guesswork because it's so complex. And AI is really just kind of predicting the next best outcome. But I think with quantum computing, these complex problems, it can solve them
Mm,
with better accuracy at a faster rate once it is really taken to the next level. I think again, it's we're so early in quantum computing and there's still so much research being done, but it's one of those things where some of the problems that AI is sort of helping a little bit right now, it's going to take it to the next level. So it's not really going to make your ChatGPT any better because you could just add more GPUs to make your chat GPT better. But what it's really going to make or where it's really going to make a big difference is probably in like medicine, in chemistry, right? Where we have so many different variables and we're trying to simulate so many outcomes.
mm.
And right now, it's just not really that powerful to be able to do that, where quantum computing will be able to enable that type of complex, like super complex work being done at, like, the same time.
Yeah, I think so. One thing that I did read on that exact note that I found fascinating and I didn't think about and is encryption. So encryption's a big thing where you
Yes.
have complex like RSA like encryption, and it works because, to your point, that it would take so long to randomly guess the string of numbers that would unlock the encryption. It's basically it's more atoms than there are in the universe. But one of the things that quantum computer like solves is, yes, it makes especially guessing numbers more efficient. And theoretically, because it's not yet, but once you get a massive qubits at a certain level, that it would allow encryption that would normally take, yeah, like exponentially long to be trivial, which I think is interesting way to you think about trying numbers. That's one of the like classic use cases. I think what you were saying is also just a general thing that I'm going to ask your opinion on is how I think of quantum computing. Yes, it's like AI because the machine learning and GPUs was sort of a breakthrough that we didn't really see coming. That if you looked at AI advancing in like the 60s and 70s when AI was first being developed, no one could really predict the jump in compute power that like NVIDIA enabled with GPUs, and it allowed them or allowed like researchers, them, the collective them, to move from, yeah, these manual calculations to doing it on the GPU instead of the CPU. And I think that's something interesting to think about for quantum computing is that even though there's maybe not a use case yet, there might be something in the future, right? It might just take that one like breakthrough of ideas in order to utilize this technology, which has these proven potentials to, yeah, solve, as you mentioned, like prediction problems or just computational cycles at a much faster rate.
Yeah, exactly. Like I think we almost would think of quantum computing like electricity or the cloud, like you don't really you're not really using electricity as like an app or anything like that, or you're not really
Yeah.
using the cloud in a very proactive way, but these are things that are enabling the rest of your life. And
Yeah.
so
It's
I
more of an
see
enabler. Yeah.
see quantum computing as being the next enabler, but the way that it's going to enable is going to be incredible, right? It's going to be the next big thing because it's going to move everything faster in terms of calculations. Like you were saying, the ability to decrypt an encryption is going to be that. I think that's going to be like the biggest sort of scary revolution that's going to come out of quantum computing. And so there will be a need at that point for algorithms for encryption. And what does quantum encryption even look like at that level?
Mm,
Like that will be something that will really be very interesting. And like, for example, crypto is really going to get impacted
mhm.
by advancements in quantum computing. But I really see it as that thing that's going to change your access to medication or the types of medication that are being delivered, right? The research that's being done on drugs
Mm.
or, uh, yeah, basically drugs. It's going to totally change. So it's going to be that thing where the world around you changes, but maybe you're not necessarily as aware of that because it's not like there's a new app that's being developed for
Yeah.
you, but the rate of development will move forward quickly. And that
Yes.
is where it will be evident to you. And that's why I think we're bringing this topic up now because we're like, you should be aware that these changes are upcoming. Like, keep an
Yeah.
eye on what's happening because between like Google, IBM, Microsoft, like these companies are all trying to make very big advancements in quantum computing. And so I think that that's the next space that you want to be tuned into
Yep.
because you don't wanna be that person that was, like, late to quantum computing if you were the one that was late to AI.
Yeah. But as you said, so I guess the counterpoint is, can you even prepare? So just like how we mentioned, like you didn't really, we can prepare for AI and we talk about that because it is a product we can use and it's slowly, and we're seeing the rapid development and how it's being integrated. So we're learning to work with AI. But from what understanding that you're mentioning, we're not going to be working with quantum computing. So should I be thinking about it as not working with it, but like, yeah, using it as part of our everyday? Like, how do I prepare? Can you even prepare?
Yeah, I don't think so, like, I don't know, like, let me know what you think too, but, like, we try well, this is what we try to do on this show, right, is try to bring everything back down to your everyday life, and I think when you think about the everyday application, maybe you're probably not gonna have an app that you open up like you have the ChatGPT app right now. But I think when you're thinking about your businesses and business problems, if you're a person in leadership, if you're working on optimization problems, simulation, I think that's when you might start thinking of quantum computing. And there are companies out there right now that are trying to scale quantum computing, that are trying to see how we can make it cheaper. And so I wouldn't be surprised if that's something that will be of access, like it will be accessible at some point. So yeah, I don't really know, like, if there's really a way to prepare for it, but I think it's one of those things that, like, if you're an investor, you might wanna be looking up these companies that are investing R&D into quantum computing. So, like, if you wanna make money, that's probably the next thing that's coming down. But I think in, like, the day-to-day, how is it gonna impact your life? It's probably an awareness piece. Like, you're not really engaging with the cloud the same way, but it is still going to enable your life. I don't know, like, what do you think? Do you agree
Yeah,
or
yeah, I personally agree, and we'll throw this back to you, the viewer slash listener. What do you think? Because yeah, if you use, as we mentioned earlier, like electricity as an analog, like how do you prepare for electricity? You don't, but it's going to cause the advent of electricity caused a cultural shift in the entire world of how we do things. Right, we went from candles to light bulbs. That was a shift, but you didn't necessarily prepare for it. But I think if I look at this like a positive outlook of quantum computing is that it's going to make certain things just like electricity, right? It's going to change industries. It's going to change how we work with computers because computers will be able to do more that we don't really know about. So again, yeah, it's hard to quantify or even outlook, but I'm of the mindset that I have a general, I guess, optimistic mindset for most of technology. I think the history has shown that technology has generally improved our lives. So I'm positive on quantum computing in general is that we might not know how it's going to change, but I think it's going to enable innovators, entrepreneurs to take advantage of these new technologies, these new abilities that are everyday computers. And then once we get there from that scale, as you mentioned all the big players like Google, Amazon, IBM, they're all heavily investing in it. So they see at least some sort of future in here. So I think it is on the horizon. It could be however long, just like everything's always 5 years away, but they see these big players in technology, they're the big tech companies. They see this as the next frontier they want to get ahead of. So I am optimistic, and for me, I'm just staying abreast of what the big players are doing, right? They're probably going to make the biggest advancements because they're making the biggest investments in the space and seeing kind of what comes down the pipeline.
Yeah, I would totally agree with you. Like, I think it's interesting topic, and I think it's coming out of, like, pop culture. Whenever
Yeah.
I think of quantum, I think of, like, Ant-Man. Or like Black Mirror episodes, like, I don't really think about it as being like a real it's kinda well, it kinda seems like a catch-all magic term to, like, explain the unexplainable or the inexplainable in movies and TVs and books, and so it kind of feels like this is actually a real topic, there's real advancements being made in this. I think the opportunity is great, like you said, technology has historically just improved our lives, so I hope that this improves as well. And yeah, hopefully we will see good things coming. So I guess for our viewers, like, let us know what you think. Do you think that quantum computing, how far away do you think it is? And do you think we need to care about it as regular people? And why?
Yeah.
Right?
So to recap, you do need to prepare. Do I need to even care about this Patricia yet? Or I think our kind of conclusion is just something to be aware of that's coming down the pipeline, that it has a lot of potential to change certain industries. I think the biggest ones, as you mentioned, things like drug discovery, things that use a lot of computing power. So encryption is the big one. That it will change it could potentially change our lives, hopefully for the better, as we're saying. It's going to be a positive, but it's definitely something to be aware of. So yes, watch your Ant Man Quantum Mania, watch your Black Mirror, watch your um totally the Blake Crouch novel Dark Matter to learn about superpositioning in this sort of multiverse. But I think the real world application is not going to be multiverses happening, but it's going to be an enabler for technology in the future.
You'll remember this episode in a
Yeah.
couple of years and be like, oh, Patricia and Zach, they talked about it. So join the conversation. Let us know what you think.
Yeah.
And thanks for tuning in
Thank-
today.
Yes. Thanks for watching. Thanks for listening. Have a great one.
Bye.
Bye.